Typical starter motor circuit consists of three separate circuits. The low current control circuit, which in this case sends power to the starter relay. The starter relay circuit, which sends power to the starter solenoid. And then the high current starter motor circuit. We'll be looking at the two control circuits, the starter relay circuit and the low current control circuit, in this series. Looking at the B positive terminal of the starter solenoid, there are three cable connections. Two red wires with yellow insulators and one battery cable with a red insulator. We're going to focus on the middle of those three, the small red wire with the yellow insulator. That is the control circuit for the starter relay. From the B positive solenoid terminal, power is sent to the firewall on the very left hand side. Out of the firewall on the yellow wire, it's going to the fuse. Shown here from the bulkhead firewall connector, power goes into the fuse on the right hand side, out of the fuse on the left hand side. From the fuse, it's headed to the back of the ignition switch. The flow of power continues. As you can see here, the yellow wire goes in to the center terminal on the back of the ignition switch and out on the white wire with the red tracer, headed towards the bulkhead connector and then the neutral safety switch. Continuing to follow the flow of power, you can see here the second wire from the left on the top row. The white wire comes from the ignition switch, goes through, makes a loop at the bottom, back up to the top row. The third wire from the left is also the white wire with the red tracer, headed towards the neutral safety switch. The white wire goes into pin 1 on the left hand side of the backup neutral safety switch and out on pin 4. It's changed colors at this point and it's headed towards the starter relay. From pin 4 on the neutral safety switch, the red wire with the blue tracer goes to the bulkhead connector, and from the bulkhead connector it goes out to the S terminal on the starter relay. The red wire with the blue tracer goes into the starter relay at the 3 o'clock position, right in between the two yellow insulators. It's a red wire, has a blue tracer and a blue insulator. It goes through the coil of the relay. The coil of the relay is grounded on the black wire with the blue insulator at the silver screw. We'll start our testing on the ground circuit, connected from battery ground to the ground for the starter relay. During cranking, the maximum the voltmeter should read is 0.3 of a volt. Anything over that indicates high resistance. Now we'll switch our attention to the insulated circuit. Starting at the solenoid B positive terminal, we'll connect the negative lead at the S terminal of the relay. During cranking, the maximum the voltmeter should read is 0.5 of a volt. If you look closely, the reading of 0.5 has been exceeded. We have a reading of 1.3, indicating that there is high resistance in the insulated circuit. Further testing of the insulated circuit will be required. Testing from the B positive terminal to the fuse input wire, we're going through the bulkhead connector. Normally we allow 0.1 of a volt for each connection and each cable. In this case, we're at 0.14, well within an acceptable amount for the number of connections in this portion of the circuit. Testing the voltage drop across the fuse block. So from the input to the output, we're allowed 0.1, and we have 0.02. Next, we're testing the voltage drop from the fuse output to the ignition switch input. The cable should be less than 0.1. We have 0.15. well within acceptable amounts. Next, we will be testing the ignition switch input to ignition switch output. Maximum allowable voltage drop is 1/10 of a volt, 3/10 if you're including the terminals, which we are not. During cranking, our reading is 0.17, which is exceeding the maximum allowable by 7/10 of a volt. Next in line, from the ignition switch output to terminal 1 through the bulkhead connector, 1/10 per connection. We are well within an acceptable range here at 2/10. Testing at the neutral safety switch, we're allowed 1/10 for the switch, 1/10 for each of the terminal connections. Since we are touching the terminals, that would be 3/10. During cranking, we have almost 0 volt drop, indicating that we are getting excellent connections at the terminals and the switch. Our last test, we're going from the output wire at the neutral safety switch to the S terminal. We have 3/10. Counting up the number of connections from the output wire through the bulkhead connector over to the S terminal, 3/10 is an acceptable voltage reading. In conclusion, we were trying to track down a 1.3 volt drop. We did find the ignition switch was faulty with a 0.17, almost twice the allowable amount. We also found from the neutral safety switch to the S terminal of the relay, 3/10. Ignition switch to the neutral safety switch, 2/10, and the B positive to the fuse at 0.14. We should keep looking for other terminals and connections that maybe we haven't tested and see if they might need cleaned to improve our voltage drop. This time we'll be looking at the high current side of the relay. Again, looking at the red wires, the larger of the two red wires with the yellow insulators goes to the starter relay through the switch of the starter relay and back on the black wire to the starter solenoid's S terminal. When we do a voltage drop, we're doing a voltage drop of the entire insulated circuit here, so the maximum voltmeter reading would be 5/10. As you can see, the voltage reading is well below 5/10, indicating this portion of the circuit is in excellent condition. Had a problem been indicated, we would do a voltage drop of the insulated circuit from B positive to the relay, across the relay terminals, and lastly from the relay to the S terminal of the starter solenoid. Testing would follow the same rules we discussed earlier: 1/10 of a volt per connection, 1/10 of a volt per cable maximum.